Hi friends, welcome to Learn Electronics channel. In this video, we'll understand a breadboard. The breadboard basically used for prototyping the circuits. Say for example, you have designed the circuit through either circuit schematics or through your bare hands. You have designed some kind of a circuit and you want to practically ensure that this circuit is working properly. So then what you can do is you can insert the components on this board. You can connect your wires as per your circuit diagram and you can test them and finalize your work practically. Or in the simple sense, what I can say is it is a tool to arrange your components and connect the components via wires as per your schematic diagram or as per your circuit what you have designed and test them. So this is a very helpful tool while finalizing the circuits in prototyping. In my hand I have a breadboard. So the breadboard, from the back side you can find the tie-up points. Okay, these are all the tie-up points, and at the edges you can find these notches. This you can use it to fix to the some other board. If you want to extend the board, then you can use these notches. Now I will turn this board. Now in the back side of this board you can remove this paper and you can stick it to any place. So you have a sticker from the back side. Now let us look at the wiring connection of this breadboard. Now when you look at it, so first of all you can find the rows. So you can see these are the rows, okay, and this is the second row, and these rows are not numbered. Similarly, this I will call as a top and this one I will call as a bottom. So this top and bottom, they are not numbered, so they have no designation here, and these are especially used for power lines. So you can connect positive supply here and negative supply. Similarly, you can take a wire and connect it here to form once again here the positive and negative. And these you can see these strips, if you see the wire, the power buses, these strips are somewhere in the center, they are divided. That means in a one row it is divided into two in some of the breadboards. In a few breadboards you can see they are continuous, and in few of the boards they will mention here W, so that this part is separate and this part is separate. That means you will have one the tie-up holes from here to up to the center, one connection. The second row once again up to here, one connection. Similarly from here to the end, one connection, and here to another end, another connection. That means there are four sections you can find in this, and similarly that applies to the bottom also. Now these are for the power lines. Now let us come back to the center of this board. In the center of the board you can find that these are the columns, the strips. Here you can find the tie-up holes are connected in the form of a column. So this side, the columns, okay, that means it has a metal strip, okay, and when you insert a wire into this plastic hole, it will go inside a metal strip and it is clamped inside. So in one metal strip you can find 1 2 3 5 connections. So like this you have total of 64 columns from here to here, and from breadboard to breadboard these numbers will vary. So these are numbered actually, like from, if you see, this is 5 10 15 20 25, so up to 60. In this way total you can find up to 64 in this board. And similarly, now the horizontally they are labeled like A first row, B second row, C third row. There are 5 rows. That means in this total you can see 5 rows this side and 5 rows this side. That means total you can find in this breadboard there are 10 rows and 10 rows into 64 columns. So you have 6640 tie points. Now you can see some gap here, okay, and this gap is exactly matched to dual inline packages, that is ICs. We can insert ICs in the center. I will just show you. This is one of the example of a dual inline package. So this gap, whatever you can see, you can exactly insert them in this way. So now let us try to explore how we can insert the components. Let us take a single wire, okay, and I will connect it to, say, here the column number 60 and now I have connected to another, okay. You can insert in this way, and this point you can see. Now I can label this. Now this is A60th, okay, this is G60, okay. You can number them in this way, and so that you can define your connections. Now if you want to insert LEDs, okay, you can insert the LEDs. So you can insert them either in this way, okay, either in this way, okay, or you can connect them in this fashion. In this way, if you connect in this way, okay, then this is a short. So this is a short. If you connect in this way, then it remains same column, then it is a short. So don't connect them in this way. Either you connect in this fashion or you connect from this to this side. So now coming back to the type of wires you can insert, okay. The wires, see, this is the wire what I have used is a single core wire, okay. And if you take a single core wire or wire, if you take multi-strand wires, then it is very difficult to insert these wires. These wires comes with a bundle with a different color, and you can use for the positive supply red and negative black, and even earthing you can use green. In this fashion you can follow, and for the signals you can use yellow. So you can follow your method, or you can follow any standard method, so that the debugging becomes very easier. So better always use a single strand wire rather than multi-strand wires. Now to do all these connections, you need few of the tools. One of the tool is, this is a wire stripper. From this you can remove the you can strip the wires, and even cut the wires also. So second one is, you need a wire cutter, okay. This is a typical wire cutter. And some cases when you are connecting capacitors or when you are connecting resistors, you might need to straighten the leads, then you need to use these nose pliers. This is an example of a nose plier. While working with a breadboard, these tools will be very useful, which I have already described. So first one is a wire stripping tool. You can strip the wires very easily, and you can use it also for cutting. But I recommend you to use wire cutting tool for cutting the wires, which will, you can sharpen them very easily, and you can easily insert through the breadboard. So third one is a nose plier. This nose plier, usually what happens is, when you insert the components via breadboard, the wires get bent, and these nose pliers can be used to straighten them, so that when you are using multiple times, when you are inserting the wire multiple times, this nose plier could be very useful. And then I recommend you to use 22 AWG, that is American wire gauge standard, single strand wires while interconnect the components via wires. So these wires, you can see them, they are a single strand. They will have only one core in the center. If you are using multiple strand wires, then it is very difficult for you to insert the components on a breadboard. Recommendation is use 22 AWG wires. In few of the cases, if you feel that these wires are difficult, then you can use hookup wires. They come both the ends, that is male or female connections, use them. Then other very important tool what you can use, for example, if you want to find the faults, then I recommend you to have a multimeter, either analog or digital, along with you.